All right, we're going to get started in a moment. And this lecture is brought to you by Moby. Moby builds technologies that expand the human ability to navigate the world. Moby's core ability is to model decision-making through a set planning platform to solve complex problems for the individual and at scale that the human brain can't solve alone. Moby's AI planning platform integrates robust data sets, capable of fleet efficiency optimization, business process automation, as well as guiding travelers to the latest meals and off-the-beaten-path experiences worldwide. Moby's ability to solve tough problems at scale is being used by the world's largest brands. Founded in the research labs at MIT in 2012, we work, build, and learn together at our headquarters in Somerville, Massachusetts. We're proud to be backed by an outstanding group of investors, Firefly Venture Partners, RPM Ventures, and Enterprise Holdings, who share a commitment to building transformative travel technologies. All right, so we're going to be talking about servers and Node. First off, what's a server? Well, here's an example of a server, but this is more of a server you can access. Like, you can access a Minecraft server, but where's that actually running? That's actually just running on a computer somewhere else. So a server is a place where a client can go to get some information. And really, you can just imagine a server as a process on a computer. And this process, you can just run it like any normal process. A client will access this server through a request, and then the process will make some response. And this, sure. So we can also have many clients, and the responses can all come from this one server. So we don't need many servers for many clients. We can actually just have one single server. And this is particularly convenient because it means that we can scale up our applications without needing to think about scaling up our server too early. So why do we need a server? Why couldn't we just do all this work in the client? Well, first off, the server gives us the ability to access files in one central place. And that leads into the next benefit, which is centralization. We can have a single true version of all of our data, our state. And we get some security benefits because we probably don't want to be doing, for example, all of our authentication on the client side. If we were to do that, then that means that, well, anyone using our website could change the code for authentication. And unless we designed our authentication protocol very well, it would be pretty hard to make sure that, well, we were actually authenticating the right users and people weren't like logging in as someone else, which would break the whole point of authentication. So we rely on servers for security, as well as for providing a single source of truth and for giving us access to shared files. But how does a server actually run? How does it know what to listen to? First off, a server is a process, and a process is an application that runs on your computer. And it listens to incoming data. But the place where it listens to incoming data from is called a port. And a port, if we imagine, a port is similar to like a port in shipping or in a harbor, if we imagine the computer as the harbor. A port then is like a place for a process to dock or listen to. And each port only holds or only can be listened to by one process. Similarly to how you can only really dock one boat in a port, in like an ocean port. And since two servers that are on different processes can't listen to the same port, this means that we need to have lots of ports for when we want to run more than one server. So the example that we've actually been going through in our workshops in CAP with React runs two servers on one computer. We run the hot loader on port 5050, and we run the actual API, or we can run the actual API implementation on port 3000. But you'll see that starting in workshop 4. The reason why we need different servers for this is actually because, again, you can't have them both listen to the same port. And yeah, and the process ideally would only listen to one port at a time. It's more convenient. So the specific way this happens is a server binds to the port. And the way you specify what port you want to connect to is by adding it to the end of your URL. So the first URL specifies that we're connecting to example.com at port 5050. So whatever server is listening to that port will see it. And the second has us listening to port 3000. And whatever's listening to port 3000 will see that request. But notably, a request to port 5050 will probably not be seen by the server listening to port 3000, because unless they're the same server, it's going to be different processes seeing those actual requests. In general, the format for a URL looks something like protocol domain port, separated by : / and with the optional port being separated by a colon. But we don't actually type this port out most of the time. How does that work? Well, it turns out that we have a lot of default ports for common ways to connect to things. For example, for HTTPS, which is HTTP, but secure, we use port 443. And when we use HTTPS as our protocol, by default, we're going to have it inferred that we want to connect to port 443 and not port, well, 80, like we would for HTTP. There are a few other ports that a lot of the other services use. A typical port for a Minecraft server is like 25565, and AirPlay uses port 5000, which is actually why the hot loader is on 5050, because it would have conflicted with the AirPlay server on Macs as of a few years ago. You can roughly imagine that like ports on a, like another analogy that might help is you can imagine a server as a hotel and ports are like a hotel room. So you have to specify the hotel room when you want to say where you're like calling someone on the phone, because otherwise, how do they know who to call or what room to call? It'd be pretty confusing. You can actually use your own machine as a server because servers are just processes. And every computer can run server code. The little caveat here is that it's hard to actually get that visible by other people. However, if you don't care about that, you can use the special domain localhost, which we've been using throughout the workshops to connect to our own servers that we host on our laptops. You can't connect to your teammates' localhost though, because they have their own localhost and they're like different domains. So to get around that, you're going to have to go through some kind of hosting service to be able to connect to them, or like figure out how to connect to them on the network, on a shared network. Localhost also works with ports. So when we connect to localhost 3000, we're connecting to a server on port 3000. And that's just like every other URL. How do we write a server though? What do we implement a server in? Well, we have a lot of options. We can use a lot of frameworks, but why would we use a framework instead of just writing it ourselves? It turns out that servers basically all look the same. Like most servers are basically the same thing, except for what they do with specific requests and responses. And that means that might sound kind of like simple, but the reason why they're similar is because you have a lot of work to do in terms of how you listen to a port. And all that work can be kind of abstracted away by a framework. So we use frameworks to abstract away the repetitive part, which is how we listen to a port and get requests and parse requests. And then from there, we can write programs that like accept requests on certain like endpoints or paths, and then they give certain responses. And that's the custom part. That's where we let the user write that's where frameworks let the user write their own code. I guess an example of this would be like, if you imagine some website like Dogbook, it'd be really similar to Catbook, except it does slightly different things. It probably shows pictures of dogs instead. And Catbook and Dogbook probably don't both need to write the same like server code or the same like server code for how they listen to ports, because it'd be the same. So instead, we probably use ExpressJS between the two of them. We teach ExpressJS in this class, but we also need a tool to run JavaScript code. And that's because, well, we've mostly been running code in the browser, but we need to run the code on our actual laptops. So we're going to be using a tool called Node.js. And Node.js runs JavaScript on your machine. And ExpressJS lets you write a server in JavaScript. So together with these two tools, you can run a server that you wrote in JavaScript on your own. Now, Joyce is going to talk to us about NPM, which is a tool for using and installing packages in Node, because it turns out we have lots of libraries we need.
Thank you, Jay. Hands up in the back if you can hear me well. Okay. So okay. So we have already seen some of Node. So when you use npm install, we're using the Node package manager. And like the name implies, it just manages your packages, right? So when you do npm install, you're installing these packages that maybe your code relies on. So when we use React, we can't just use the .js like file. It has some libraries that have pre-existing code that we don't want to write ourselves that React relies on. So we can install that using npm install. We also run npm run hot loader. And what this does is basically it runs our front-end server so that whenever you make a change in your code, it will automatically reload on your web page. So every project has some necessary information. And so what we mean by this is like it has project metadata. So this metadata is actually held in package.json. And what metadata is just, it's not exactly code, but it's just information about your project that is in code itself. So here's an example of a package.json, and we can see there's different information that might be useful for our project to know. And what we really care about when we do npm install is the dependencies. So in the dependencies, this is what npm looks for to know what it has to install. So when you run npm install, it will install all the packages listed in dependencies and put them into node modules. So we can actually go to our Capbook and see this ourselves. I'm just going to demo, so you actually do not need to have your laptop open. But if we go to our terminal, and I'm just going to check out W4 starter. So here now, we can go to package.json, and we see that we have all of our metadata, and we can see down here in dependencies, we have all the different packages that that our files rely on. And then we can see when we ran npm install, it should have created this node modules folder that have all of these different packages. You can see it's like grayed out, and this is because in git ignore, we ignore node modules folder. And this is because it's such a huge folder with all these different packages, and like we don't want to push it to GitHub because then it would be slow. Okay. And also like if we have any dependency updates, it might cause like conflicts. So this is why it's ignored when we push it. And this is why we also npm install every time we pull. Okay. So now, previously we just mainly worked in our client folder. And so this had all of our front end code, including our React code and components. But now we have something called a server. So in our server folder, it'll have all of our backend code. And then there are some other files, but you don't really need to know or understand them. But if you are like confused or if you are curious, feel free to ask the staff. Okay. So the first thing we're going to do is go to our server.js folder, and we'll see right here, all we do right now is use require to import express. So essentially in the backend, you use this require keyword, but if you remember in the front end, how you imported things was using import. So that's one difference in the backend. And then the first step we do is we create our express server and we name it app. Additionally, we see that there is some code to hard-coded our port. And right now we have hard-coded it to 3000. And this is our port for our backend server. So this isn't our front-end server. So if you recall, we use localhost 3000 to run to view our server. And then for our front end, we do localhost 5050. And the place where we define our backend server port here, but the place where we define our front end server port can actually be found in our scripts in our package.json. And we see that it's defined to be port 5050. Okay. So our first thing we're going to do on our server is create our first API endpoint. And so you can see that there's a lot of components to it, but the first component we'll focus on is the HTTP method. So we're using a function from Express called app.get. And then here we say .get, but if we did app.post, then we would be making a post endpoint. The next part is the Express route. So this is just the address of our endpoint. So when we go on, for example, localhost 3000, if we did API/test, that is the address and that's the root path. Okay. And the last part is our function handler. So this is the function, the callback function that we want our endpoint to run after we find some match to this endpoint of API/test. And what we'll do is first, this function will take in a request and response. And so the request is just the incoming request. And this has the information from our front end, and it has information that maybe we will want to need. So request is how we get incoming data. And then response is how we respond, so how we send data back to our client. And we can see that we use the function res.send to respond and send back a message to our front end. So as a summary, the app listens for a request that matches the specified method, which here is get, and then the specified route, and here is /API/test. And then when it does detect a match, it will respond by using the callback function that we specify. So we can go, or I'm gonna go check out W4 step 1. And now we see that we have our /API/test endpoint. So how can we run our server for our backend? We can run it using npm start. And we know it's npm start because in our package.json, we have it defined here, and that will run our server. Okay, so now our server is running on 3000, so we can just go to localhost 3000. And if we give it our API path, we should be able to see our message. And then remember how we hard-coded the port for now. So if I change the port to 3001, then if I refresh, it doesn't work. But if I change our address to be 3001, we should see our message again. Okay. So nice. We have made our first API endpoint. So when we're defining our API endpoints, order does matter. So we must define our endpoints from most specific to least specific. And this is because when Express tries to find matches, it'll just match the first one it sees. So if you defined, for example, /API/star, what this does is match like what the star does is basically it matches every and any character. So any number of any character, it will match. And if you know regex, it will kind of look familiar. So basically this matches /API/a/API/gibberish. It'll match anything. So using this knowledge, which of these two options do you think is correct? So show of hands, 1 or 2. Okay, so most people are saying 1. And this is because we want our endpoint /API/test to be hit. That's why we defined it, right? So if we did number 2, then this would send endpoint B for all requests that have /API/, and that includes /API/test. So we would never hit this endpoint if we had it defined as number 2. Okay, sometimes we want to run code in between receiving a request and running our API endpoint code. So what we can use is middleware. And middlewares are just like workers in an assembly line. So once we receive a request, we can use middleware to pass the request and modify. For example, when we receive a request, maybe we want to parse the body, or we want to log, or we want to do different activities. And so what we can use is middleware. And they're also called in the order of definition, just like how API routes are called in the order of definition. And Express allows us to add this middleware by using app.use. And so basically what this does, for example, here is like every request that comes by, we will parse their JSON files, and so make it into a string so that we can understand. And so this is different from a API endpoint because this is going to be applied to like all of our requests that come in. So app.use takes a optional path, and a middleware object, which is often a callback function. And so what this code does is basically for every request that comes in with this root of /time, we will be applying this callback function before we hit an endpoint. This is code without the optional path. And we can see the parameters for middleware is very similar to what we saw for our API routes. So it also takes a request and response, but it also takes this optional next argument. And so this next argument is a way to call another middleware to be immediately after. And if no next is passed in, it will proceed to the next middleware defined. Additionally, we have error middleware. So error middleware takes actually 4 arguments. So it takes an error, request, response, and then the optional next. And the error just contains information for displaying our errors nicely. Additionally, we want to define our error middleware last so that as we go through our stack of middleware, if an error occurs, we want it to happen at the end. So we can see the middleware parameters, and then we can hand in our error handling code. So it's okay if middlewares is a little funky or not clear right now, but as we go through our workshop, hopefully it is a little more clear. So here are some common HTTP status codes. So we have 200, which is okay, and then we have 401, 44 not found, and then 500 internal service error. And we can send these status codes back to the client using response.status and giving it the status code. So say we wanted to throw an error, or say there was an error in our API/test endpoint, what would happen is if we go to our localhost, we will see that the error message appears. And then if we inspect, we can go to our console and we can see that there was a 500 internal status error. So here it's kind of displaying an ugly message, but maybe we wanted to send to our front end a better message without all of our traceback calls. So what we can do is create our error middleware to handle our errors. So adding error handling, like we said before, you use app.use, and then we pass in the 4 arguments: error, request, response, and next. So what this line does now is it checks error.status, and if the value is none or 0 or false, then it'll assign the value of 500. Otherwise, it will keep the value of error.status. So if error.status had the value of 200, then status will be set to 200. Otherwise, it'll be set to 500. And if the status is 500, we can print some more useful console log statements, and we can print the error as well. And then we want to set the status to be whatever status it was, whether it be 500 or 200, and then send it back to the front end. So if we check out next step, we can now see our error handling code. And so now if we go back and throw an error once again, instead of seeing this message, we can now see the status and then a message. So this can provide our client more context or more information by using our error handling code. If you don't define your own error handling code, Express has default error handlers. So that's why we would see our previously when we didn't write it, we still saw some our error message being sent. Okay, so now we have handled when we have an error inside our code, but what if we wanted to handle when we go to an address that doesn't exist? Right now we just see cannot get, and then the path, but maybe we want to display something more useful. So now Jay is going to introduce the concept of a catch-all endpoint to handle these cases.
All right. Am I audible at the back of the room? Okay, cool. So let's go back. Okay, so at the moment, any endpoint that we don't actually define is going to hit, or what if we define a star endpoint, all endpoints that we don't actually specify, or all requests that don't go to any particular endpoint, are going to go to the star endpoint. This is pretty useful if we want to handle like traffic to static pages. Because for example, if we have a React app, we have a lot of web pages that are getting requests. And those web pages, we probably don't want to write a new Express route for all of them, because then we'd have to write a route both in Express and we'd have to write our React routing code to correctly navigate between them. And that's pretty error prone. It's also like just not great. Like it's just twice as much code as we actually need. So instead, instead we can use a catch-all endpoint. I guess a concrete example of when this is useful is, let's say we have some static like web page /game. And when we go to /game, we want to access like our game on the site. Let's say we made like a platformer or something. Then we don't want to have to associate /game with the HTML code of our, or like with something serving the HTML code of our game, or the HTML and JavaScript of our game. Because if we did that, then we've also done it in React, because when you click on the game button, we expect that to navigate to the game as well. And encoding that twice is inconvenient. And like, if we have to change the URL at some point, it's going to have to happen twice, and it's just not fun. So it turns out that since React already knows where every page should go to, we can just redirect all requests against the star endpoint to the same page. And that's like the main thing that we're going to be using here to make this catch-all endpoint useful. So hopefully that makes sense, but we'll see some code examples of how it works in a bit. So first of all, here is what like all the, that's 40. Okay, we're going to start by importing some libraries. And first, we're going to actually import Express. And we're going to import this library called path, which is really convenient for working with file paths and concatenating them in ways that are like work in a platform independent way. Because I don't know if any of you are on, like some of you are on Windows. It turns out that Windows has different separators in paths than Unix does. So like functions like path.resolve down there are aware of that and will use the right separator. And it's better than having to write the code yourself and having it only work for one platform. So first, we're going to have this API route defined just as an example at API/test. And we'll go over more of what this code actually means in the workshop. That's not the super important part, but we support a GET request against API tests, and we ignore the request, and we send back a response of, wow, I made it for my first API. So this code, what it's doing is, first, we construct a path to all of our React files. And that path lets us use the express.static middleware that we talked about middleware in general before, to serve React files as static content. Now, what this actually does is it means that we sort of like pull all those React files into a place where we're able to like provide them with the send file function that we're using later, because without that, we wouldn't actually know like what file, or like we wouldn't have access to those files. So express.static kind of gives us access to those files, even though they're already in our file system. And the path we're using here is like, so dir name is the current directory. Then we do ... client dist. So the current directory of this file would be in server somewhere. So ... is going to take us out of server, and then we're going to get into client, and then we're going to get into dist. And that's the place where all of our React files are compiled into like HTML and bundled JavaScript. So lastly, for any route that or for any like route that we don't actually know, we're just going to send the file of like client dist index.html. I got the client dist part because we're joining React path with index.html. And this works because React knows how to do routing. So when it sees that we have a request for example, /game at index.html, the router in React itself is actually going to send us to whatever page for game that we made in React. So React is handling all of the, so React's routing is handling all of the work of getting us to the right page, even though we are only redirecting to like the root page, like the home page of our site. And if we look at all this together, this is a simple Express server that like correctly implements an API route, but it also, for every other route, sends over React files. So we could use this one server to also serve our React files, and we wouldn't really need to use our hot loader. Well, the hot loader is nice for other reasons, but assuming that our front-end files never changed, we could use this instead of the hot loader, and we would just have our server running on like whatever port we said that we specified this to run on. And we'd be able to see all of our React content through it, instead of needing to run some separate server as well for serving the front end. Hopefully this code's like fairly understandable. If it's not, we'll talk about it more, or talk about codes similar to it more in the workshop, and we'll go over that in a lot more detail. So let's see what it actually looks like when we go to one of those pages that doesn't exist, or that does exist somewhere else in our app. Is the code big enough for everyone? Okay, cool. All right, and it's right here. That's yeah, so our API still works. And let's see if we have other content that works. Okay, this no longer says we have an error, but it should be, but I think it's not routing to any React content because we don't have anything at foo. But let's go and see if we can get through it. But this is a different behavior that we're like pretty happy with, because we aren't because like we're not seeing an error message about this page not being found. And wait, why is this not? 1 second. We're going to run the hot loader and just see if that resolves this, because I think something might be misconfigured, but it's fine. What's up? Yeah, let's try that. I make no changes.
But you don't need a hot loader.
I agree, we shouldn't need the hot loader. Why would it not work yet?
I don't know. Oh.
Wait. Sorry, we're running into some technical difficulty with the demo. I'm slightly surprised this doesn't work. Oh, that's why. But fixing that is hard.
Okay.
I've seen that before.
So what it should display is basically just your index HTML you see on the front end.
Yeah.
It seems like the error is that when we build our bundle.js, it gets created wrong somehow. And like when it gets created wrong, it stops the entire page from loading instead of like having a nice error. So I'm not exactly sure why this happened. We'll look into it and get a better explanation, or like a more clear explanation for why.
But essentially a catch-all endpoint is just when there's a path that you haven't defined, you want to display something maybe aside from just like the page is not found. And so you can use this catch-all endpoint to specify that behavior of like what you want to display when there is not a path for that name that someone tries to access.